Hello everyone, from group 2, we will present about 4.1 thermal equilibrium. Thermal equilibrium between two objects is a condition where both objects have the same temperature and there is not yet flow of heat between the two objects. When two objects are in thermal equilibrium, the temperature of the hot object will drop while the temperature of the cool object will rise until the temperature of both objects become the same. Net heat transfer between two objects becomes zero. Both objects are said to be in thermal equilibrium. Flow of heat energy and thermal equilibrium. Hot object P is in thermal contact with cold object Q. The rate of heat transfer from P to Q is higher than the rate of heat transfer from Q to P. Then there is a net transfer of heat from P to Q. Therefore, temperature of P drops and temperature of Q rises. Temperature of P and temperature of Q become the same. The rate of heat transfer from P to Q is the same as the rate of heat transfer from Q to P. Net heat transfer between P to Q becomes zero. P and Q are in a state of thermal equilibrium. Thermal equilibrium in daily life. Heating object. Hot air in oven is thermal contact with Calbrate. Heat from the hot air flows to the Calbrate. This causes the Calbrate to be heated until it is baked. Clinical thermometer is placed under the tongue of a patient. Heat from the patient's body flows to the thermometer until the temperature of the patient and the thermometer become the same. The body temperature of the patient can be determined because thermal equilibrium occurs. Cooling object. When food is kept in the refrigerator, heat from the flows to the air is in refrigerator until thermal equilibrium occurs. Temperature of the food drops and the food stays fresh from a longer period. Drinks are cooler by adding several ice cubes, absorb heat from the drink, and milk. Milk ice cubes absorb heat from the drink until thermal equilibrium is achieved.
To calibrate a liquid in glass thermometer using two fixed points. Calibration is a process of making a scale of reading on a thermometer. The process of calibrating uses the thermometric property of liquid in glass. Thermometric property is a physical property such as lack of column of liquid in the thermometer which can be measured and changed with temperature. Thermometry that does not have a scale can be calibrated using two fixed temperature points. There are lower fixed point and upper fixed point. Lower fixed point is melting point of ice, 0 degrees Celsius. It is determined by measuring the lack of column of the liquid in the thermometer which is placed in the ice and distilled water as shown in diagram 2. Upper fixed point is boiling point of water, 100 degrees Celsius. It's determined by measuring the lack of column of the liquid in the thermometer which is placed in the boiling distilled water as shown in diagram 3. To calibrate a liquid in glass thermometer using two fixed points, diagram 4 shows the measurement of L data from 0 degrees Celsius until delta degrees Celsius and the measurement of lead L 100 from 0 degrees Celsius until 100 degrees Celsius. The formula to determine temperature data from an object or liquid using calibration is data equal L data dividend L 100 and multiple with 100 degrees Celsius. And for example, to determine temperature data by using formula method, L 100 equal to 12 cm and L theta equal to 4 cm. When data equal to L data dividend L 100 multiple 100 degrees Celsius, and you can substitute the substitute, and you will get 20 33.3 degrees Celsius. Or you can use ratio method. When L 100 equal to 12 cm, 12 cm equal to 100 degrees Celsius, 1 cm will be 8.33 degrees Celsius. When L theta equal to 4 cm, the 4 cm will be 33.3 degrees Celsius. That's all. Bye.